Welcome class. Today is, I don't know the date, it's about May 17th, and this is pre-calculus. Today we're going to be learning about trig identities, and specifically verifying said trig. I'm going to show y'all a few problems on verifying trig identities to get you in the hang of it and see how they're done. Problem 1. Notes on verifying trig identities. Alright, the most important part about this whole thing is underlining the title. You gotta write today's date. Alright, now problem 1. Alright, this one is a little bit difficult, but I know y'all can do it. Alright, so cosecant of x divided by cotangent of x plus tangent x equals cosine x. Now, they're already equal, so you know if this one equals, say, 3, then this one also equals 3. But to do this, you must cross multiply is your first step. So now cosecant x equals cosine x times cosine x over sine x, because that's what cotangent is, plus sine x over cosine x, because that's tan is sine x over cosine x, and cosine x is over sine x, which you learned last lesson. And now, for the next step, you take cosecant x on the left side equals cosine x times cosine squared x plus sine squared x cosine x, because that's when you add these up, you must times the bottom of this one by sine and the bottom of this one by cosine, as well as the top by cosine and the top by sine, because when adding you have to do the common denominator. And now you say secant x equals cosine x times 1, because the first trig identity is cosine squared x plus sine squared x equals 1. So times 1 over cosine x times sine x. Alright, so the next step in this equation is cosecant x equals cosine x over cosine x times sine x, because when you times it out, that equals cosine x over cosine x times sine x. And the next step, you just cross these out, and that leaves you with 1 over. Alright, so now we're at our last but not least step. And now you already know that cosecant x equals 1 over sine x due to the reciprocal trig identities. And since cosecant x equals 1 over sine x, the only thing left to do is write 1 over sine x. The next example we're going to be doing in our lesson is a sum identity. And what I have for you is the sine of 75 degrees. So you can't just do this using the unit circle. But what you can do is do the sine of 45 degrees plus 30 degrees, since you already know the sine of 45 and the sine of 30. For a sine identity, you do sine A cosine B times cosine B sine A. And then you always do positive with positive, and if it's a minus, then you do minus over here with sine identity. So sine 45 degree times cosine 30 degree plus cosine 45 degree sine 30 degree, since it's cosine B sine A plus cosine A sine B for the problem. Alright, so the sine of 45 degrees is root 2 over 2. The cosine of 30 is root 3 over 2. Plus the cosine of 45, which is root 2 over 2, times sine of 30, which is 1/2. Now we're almost done, because once you times these, it's root 6 over 4. And once you times these, it's root 2 over 4. And now once you add them up, you get root 6 plus root 2 all over 4, since same denominator. And our third example is from double trig identities. So if the sine of m equals 12 over 13 in quadrant 1, find the cosine of 2m. Well, to do a double cosine of m, cosine 2m, the easiest equation for this would be 1 minus 2 sine squared theta, or 1 minus 2 sine macro. Alright, so a double identity for this would be 1 minus 2 times sine 12 over 13 m squared. So 1 minus 2 times 12 13 squared. Alright, so now since you can't do 1 minus 288 over 169, you have to put this as 169 over 169 to equal them out. Minus 288. So you're going to get a negative number here. And that negative number turns out to be 119. So the answer is negative 119 over 169. Thanks for tuning in to this episode of Precalculus. We just learned how to do Pythagorean theorem identities and trig identities, as well as double identities and some difference identities. So